All right, so I'm going to be talking about homework 3 and my solution for it. So starting off, pretty simple. We have a cable under tension and under its own weight. We're given our differential equation here and written that. Pretty simple, the FPD and cutting it. We've done this, 100 times before as engineers, so I'll try and go through it pretty quickly. Reaction forces, solving for the Y and moment forces, just summation of those, and then plugging that in and integrating it twice. So we get two integration constants, C1, C2. C2 is 0, C1 is there. The solution for the anequal solution is right there. I wrote the mass deflection because I thought might as well. Moving on, part B, pretty similar. We're going to be taking the sinusoidal approximate solution, which should be pretty good, and then looking at H2 and H4. And then we are going to recall our BCs here, and we're going to use those later for sure. And then we're just looking at the derivative of y, approximate solution, plugging it in, doing that, taking the derivative with respect to a, we get that, and then so a, we're going to plug into y of x, and then so that's our approximate solution there, boxed it, looking good, looked at h divided by 4, h divided by 2, and h divided by 4, which we get right there. And then, yeah, so just looking at this, we have one graph here, pretty clear. It's a simulation. Nothing in real life would look like this unless somebody really messed something up. The only correct thing here is that the total magnitude and change in deflection, but the shape is completely wrong. This one's a lot better, but kind of the same thing here. Just it's obvious it's a simulation because you see the straight lines there, which are approximating the round curve of the sinusoid graph, but it's looking a lot better. And then the final one's looking really good. Obviously, we still see some gaps and stuff in there, but it's a lot better, which is what we could understand with the resolution. There's the code there. And then as it stands for D, cosine of x probably not going to be great because of the boundary conditions. Like I said earlier, we're going to be looking at those again. Boundary conditions are really important to understand, and you can always look and see what the shape of the graph is. Pretty simple. Just throw it into Desmos, and that's like a basic idea to get what it's going to look like. And so it would need a little work to essentially flip it to sine, and then you could work from there. But probably not great. For E, yes, this quadratic. This will definitely be a more sufficient model, and it would suffice for most needs. Once again, you can just pump up that resolution number, and then you'll be looking good. So that was my homework. I hope it all makes sense, and I'm sure the professor will post the solution so you can see what he did.